Dear students, welcome to the second part of the testing video series where we'll talk about unit testing. And for unit testing, we'll use a library called Jest, like the jester in medieval times. And that's a very cool testing library where all of the things that you usually need for testing is already included. You don't need to have different tools for structure, for assertions, for snapshots, and all of those things. It's very easy to use, it's very popular. You can have a look at the Jest website to learn about its origins and what projects use it and what it can do for you. And of course, there's really good documentation, because I will only recommend you libraries that have a good documentation, which is very easy to read and has lots of nice examples. And it also has a very good API documentation. So there are a lot of global functions that Jest provides in your tests, like of course test and describe for your testing structure, and after all and before all, after each and before each HUXE to run some code before your tests. Then there's documentation of the whole assertion library. As you can see, there are a lot of assertions that are possible, and documentation on the mock functions, on the global Jest object, on the configuration, and the CLI. So to get started, you can just check out their getting started example, which is only 4 files. I have it here in my WebStorm IDE. So in the basic example, there's just a package.json file, a bubble RC file, a sum, and a sum test. So in its most basic form, if you don't even use bubble, Jest is just a single dependency. A dependency on Jest. So when you install Jest, or when you add Jest as a dependency to your code, you can just write Jest in your IDE, in your CLI, and then you can see all of the options that the CLI provides. But running Jest is then just calling Jest, so I can write npm test, and it will run all of my Jest tests. Now, I've copied the sum test, so it's written in ES6 once and in ES5 once, which is why we run 2 tests now, and you can see Jest running here. And I don't know why it takes so long now, maybe because I'm recording, but it's usually in the seconds or milliseconds. And then it has run all test suites. There's also a watcher that you can start when running Jest with the watch argument. So you can see Jest --watch, and restart the watcher. The watcher even has an interface. So first it runs all of the tests, and then it will only run the tests where the code has changed. And there's even some hotkeys to change the behavior of the watcher. So you can filter it, you can quit the watch mode, you can run all tests again, you can run only field tests again, and all of those things, which is cool. Now I will quit, and let's have a look at a test. So we will just have a very basic test here where we test a pure function which sums up 2 numbers. So this is the module, and it only exports the sum function. And by default, Jest looks for any file that has .test.js in its name. So many projects have the test in the same folder as the module or the code, but some tests have all of the tests in a single folder. It depends on your style and your preferences. Now, when I look at the test, I can see that there are a few functions that are now globally available in my test, which is what you've seen in documentation. So there's always a test function available, and all of the assertions are also available in your test. You don't have to require them. And then you can write tests. And in my test, of course, I have to assert something like that the sum of 1 and 2 has to be 3. And you can see this play button here. So my IDE supports running tests directly from the IDE, which is nice. And what it does is, of course, also just calling Jest in the command line. Which is the same as just running Jest. a command line, and you can tell it to run only specific tests. You can tell it to run a test based on a glob pattern or a folder, whatever. And you can rerun it here as well. Now, this can be more tests. You can write more tests. You can write a failed test, for example. I can tell it to be 5, which is of course not true. And I can even wrap all of this in a describe block, like basic math. And yeah, in my describe block, I will then have these 2 tests. So this way you can structure your tests. And then I can run all of them again. And if my watch is still running, no, it's not, but it should now have updated as well. So this is very easy, actually. Now, another thing that's interesting is, let's get to the setup. I've now shown you the getting started, but your code will most likely be written in ES6 or in ES 2015 plus, or in the modern JavaScript, which is why you want to run your test through Babel, so you can use all of the new features. And you don't just have to, it's not only do you need to transpile the code itself, but you also need to transpile the test files. And there's a library Babel Jest for that. And as soon as you install it, Jest will use it. So when you install Babel Jest, which I have done here, it will automatically transpile all of your ES6 code. And here you can see what a failed test looks like. So I've written this test that has to fail because 1 and 2 is never 5. You can see the test output of Jest. So yeah, it expected a value of 5, but it got the value of 3. And this looks a bit garbled in my IDE. That might actually look better in here. So if I now tell Babel to just run the sum test.js test, CLI call then actually looks like this. It will only run the ES5 version, which has my error. And yeah, this is the actual error output, which looks a lot nicer than in my IDE. I don't know why. It gives you a very, very good overview of what has happened. So it tested the assertion expected received to be expected, but of course 3 is not 5, so it has failed, which is cool, which is also very readable. Now, when you install Babel Jest, you can write ES6. So here I don't have a module exports like in CommonJS for Node.js, but export. I also write a default export, and then you can import it. And this now also works. So there's not a lot of setup and configuration that you have to do, which is cool. Cool. Now, writing tests. So this was more of a setup, and yeah, when you write actual tests, you can use any of the matchers. Yeah, Jest calls them matchers. I would call them assertions. There are assertions for all kinds of things. For testing if something is in an array, if an object looks like another object, if a function has been called, if something is a string. So just have a look at all of these matchers. You can also throw exceptions and test them. You can also add your own matchers and do whatever you'd like. There are some examples in the Jest documentation as well. So the easiest, of course, expect something to be something else. You can test that an object has exactly the properties that you want it to have. You can also insert a not, so it's still very readable. And there are different ways of testing for truthiness, like expect n to be null, to be defined, to be falsy, whatever. You can also test numbers. You can test them for equality. You can test if they're larger or greater than what you want. You can also test strings and parts of strings. Everything that you can imagine can be tested. So, and now let's have a look at asynchronous tests. Because in JavaScript it's very easy to write asynchronous code with callbacks, promises, async await, and all of those things. So you will have to test asynchronous code at some point. And there are different ways to do this in Jest. Now, one is with the done callback, or with the done function that I've already told you about. So fetch data here might be an asynchronous function because it has an API call, and at some point the callback has to be run, and when the callback runs and receives peanut butter, then the test succeeds. But of course the test has to know when all of this has happened. So you have to call the done function at the end of your assertions. This is one style, and then there are other styles. For example, you can tell the test that it should complete after a certain number of assertions. So if you have 3 assertions and only 2 have occurred, then your test runner or Jest knows that it still has to wait for something else to happen. So yeah, here you can just return the promise and its 10 function, and yeah, you're good to go. But of course, with each assertion that you add or remove, you then have to change this value, which is why the other ways of doing asynchronous tests might be more stable. Now, yeah, you can also just test if a promise resolves to a correct value. You can test that a promise rejects to a correct value. So testing promises is as easy as testing callback functions. And of course, you can test async await. Async await also makes it very easy to test stuff, because then it looks synchronous. You don't have to return anything. You just have to write the async keyword in front of your test function. Yeah, I think you can also omit the assertion here, which is cool. Now, you can write test or it doesn't matter in Jest. You can also write describe. Then there are functions for setup and teardown, which I've also already mentioned, that you can run code before and after each test, or before and after all tests, where you have to set up stuff, for example. For example, you need a basic HTML structure that you want to test, or you want to mock stuff first, or you want to instantiate your view instance only once. These are all use cases for these functions. Now, you can also just test subsets. You can write the .only method after the test method, and Jest will only run this test. This also works for describe, and you can also skip certain tests if you want. Or you just write the name of your test files in the CLI. You can also do this. And yeah, just run the tests that you're interested in right now. Then there are, of course, mock functions. So Jest doesn't have it doesn't have a clear difference between spies, stubs, and mocks. All of it are mock functions. So a mock function is very easily created by calling jest.fn. Jest is also a global object that is available in all of your tests. And yeah, with your mock function, you can do all sorts of expectations, like it has to be called once, it has to be called with the exact arguments, yeah, and stuff like that. Just have a look at the API. You can also write custom matches if you want. So to be called with first arg, second arg can be simplified into another matcher that's called to be called with first arg, second arg if you want. Yeah, just write whatever you'd like. Well, then there are, of course, mock return values. So if you have a mock function, you can tell it to always return 10 or x. In this case, if you don't do this, it will return undefined if you call the mock function. But you can give it, let's say, a playbook, so that the first return value should be 10, the second return value should be x, and all the other return values should be true. But of course, you can also just tell it that each of them has to be true. Now, maybe another example would also be, you can also write .mock implementation, or you can just pass a function in here, so you can always return what you want to return. Let's see if I've skipped something. No. Okay, cool. Now, mocking modules. In your code, you will most likely also use modules. You might write modules yourself. You might use modules that already exist. So in this example, I have a basic API call with Axios. Axios calls a users JSON API, and it then, gives me the response. This is something that you don't want to do in your unit tests, because now your unit test depends on a users JSON file being available somewhere. And of course, you also don't want to test if Axios is actually working, because that should be tested. So what you can do is mock Axios. And with Jest, this is very easy to do. In its basic form, mocking modules is just calling jest.mock and the module name. And this will allow you to mock all of the exports of this module. So you can then just override the get call, for example, with a mocked resolved value, in this case data users, and use this in your tests. And then no API call will be made, which is cool. Okay, here's the other slide that I was looking for back then. So with mock functions, you can pass a mock function to the constructor or to the factory, but you can also later on use .mock implementation. So if you use jestfn to create a mymock function, you can then use mymock function .mock implementation, and you can also use mock implementation once. You want to have different responses each time you call the function. Now, what we've done with Axios was called automatic mocking. There are also manual mocks. So when you have a more complex module, you might want to mock its functions, and you don't want to do this in each test, so you can write manual mocks. And manual mocks are always in the same directory as the module, in a magic folder with _mocks, _. So if there is a __, Jest will use the mocks. If you want to use, if you want to mock a node module, you have to have a top level or a root level __ mocks directory. And an example where to put stuff is if you want to mock a module called user, and this module is in your models directory, you will have to create a __ mocks directory in your models directory and put a user.js file in there. Let's do an example. So for example, you might want to use the low-head function in your code, and you can mock this function. So here the test is just in some test folder, it doesn't really matter where this is, and it uses low-head and it expects it to equal 5. Of course, this won't ever be true, but you can mock low-. So it's a node module, which is why you have to create a top level mocks directory, and in there you create a file that has the same name as the JavaScript module. And here you can use jest.generateMock for module, and then you can mock all of its properties and functions. So in this case, low-head will always return 5, and then you can test this, which is good. Now another thing that Jest provides is snapshot testing. This is also cool because you can render output and then compare this output to the last snapshot. So a snapshot test might look like this. You render something and you match your snapshot. Snapshot itself looks like this. It just has the HTML output of the function. And you should try this out. I don't want to go into the details here. You can also update snapshots interactively then in Jest, so you can let it run each test that has a snapshot and then decide I want to update it or I don't want to update it, which is available in the interactive snapshot mode. Now, because all of your projects are written in Vue.js, we should talk about writing tests for Vue.js. Now, most people write tests with Jest for Vue.js, and there's a library called Vue Test Utils that you can use for testing your Vue.js components. Now, of course, the Vue Test Utils also has guides and has an API that you can look at, and it also has a few getting started examples, but I've checked them out and I will show you them. Now, just a quick heads up. Again, it's a ViewPress document with a very nice guide with various use cases that you might have, and API documentation. So it's a very small API, it just has a few functions. And we get to the wrapper in a few minutes, but you might want to have a look at the wrapper API. So the way the Vue test utils work is they take your component and they mount it in isolation. Meaning there is now a component that is mounted in the Vue test utils, and it runs through the whole life cycle. So you can mock the inputs and then test the outputs. For example, you can pass props to the component and see how the component behaves, and you can test this. And when you mount a component, you will get back a wrapper for this component. And with this wrapper, you can have a look at the text that's been set in the component. You can have a look at the properties. You can have a look at the events that have been emitted and all of those things. So this is how testing JavaScript components works in general, and also in Vue test utils. They also have a few things that make testing Vue.js components a lot easier. For example, it will update every DOM changes synchronously. So in your Vue.js code, you might have to call Vue next tick if you expect DOM updates in your code, but you don't have to do this with Vue test utils, which is nice. And you can also shallow mount components. So if you have I don't know, for example, a layout component, this component will have a lot of child components. And to make your tests faster, you can do a shallow mount, which means that the Vue test utils will stop all of the child components, which will then, of course, be a lot faster. Yeah, and the wrapper automatically records all events, so you can just have a look at what events have been emitted in your assertion functions, which is also cool. Now, to a basic example, let's go to the other project. Now, of course, you just have to add the Vue test utils dependency and be done with it, and then you run jest. So the test.js here is still a jest test, but I import the mount function from the Vue test utils, and I import a very simple counter component that will be tested here. So the counter component looks like this. It's really just a template where I can implement data, and yeah, that's it. So it's just a very simple example. Now when I go back here, I have a describe block here, so everything is nice and tidy. And the first thing that you will do in each of your Vue.js component tests is you mount the component. Then you have a wrapper that can do all sorts of things. Maybe the auto-completion works here. Yeah, a wrapper gives you then the possibility, of course, to access the Vue model itself if you want. But there are also helper functions like test, trigger events, set data. You can set the props and do things with your Vue.js instance. Now, a very basic test might be that the component renders the correct markup. You can go here and run this jest test, and it should tell me that when it's instantiated, it should render a span with a 0. That's cool. Now, you can also test that the wrapper contains certain elements, like wrapper contains button, and you can do stuff with your component, which is more interesting. Now, you can first test that the count is at 0. Then you can look for the button. If you use the find function, a new wrapper will be returned. So the button again is another wrapper. And you can trigger a click on the button, and then the count should be 1. Let's just quickly run this. So this tests the property itself. So it tests if the property count has been increased by 1. Which is cool in itself. But of course, we might also want to have a look at the DOM changes here. And here again, we do have to use the next tick. So if I want to run this, release function. It's written a bit differently. It looks for a text and it should contain 0. So this now looks for the actual rendered output, not for the properties. So it tests the text that has been written, it still looks for the button, it triggers a click on the button, and then we wait for the DOM changes to happen. And then we can test if the text contains 1. And it works. Now, I've told you that the view test duties applies the DOM changes synchronously, but that's not true when you do interactions on the Vue.js instance. So if you have a lot of, if you have changes in your code and there are DOM updates in your code, you don't have to call await next tick, but when you interact with the event, you might have to call it. And yeah, another thing that's a problem here in this test is that all of these functions run after one another and they all use the same wrapper. So up until now I've run only single tests and all of them worked, but when I run all of the tests, you can see that I will have an error. Why might I have an error? So the last test now fails. There's a red X. And it fails because after running this test, the button should increment the count. The count, of course, is at 1, so it's not at 0 here. And when this happens, you might want to think about mounting your component not before all of the tests, but in each test separately. So you can put this wrapper in a before each if you want, and mount it and mount your component before each test to prevent stuff like this to happen. Now, I think in the slides is another example with a username. And yeah, here we shallow mount the component, we look for texts and we look for components, and if they have been rendered, yeah, it's just another example. Yeah. Now, when you're starting to write tests, I recommend you to write these, to read these common tips before using the Vue test duties. And as soon as you're trying to test asynchronous behavior, you should read these two articles or parts of the documentation. They're not that long, but they explain very well how asynchronous behavior can be tested. And if you want to test the Vue router or something in your state, there's also a section in the Vue test duties documentation that can give you tips on how to do this. And of course, if you have any questions, just hit me up. And for your projects, I would like you to write unit tests for your components. You don't have to have a very high test coverage, but I want to see that you have a working setup, and I want you to test, 2 or 3 components and have in total maybe, 10, 20 tests. Depends on your projects. So the main goal would be that I get a feeling that you have understood how to test Vue.js with your test duties. You can also send me work in progress and ask me if this is already enough, and I can give you an answer if you want. So that's it for now for unit testing. Testing in Vue.js or in any single page application framework is very easy because you can mount the components in isolation. It's you don't need a server. It's easier than with traditional web applications. Okay, well then, that's all for now, and see you in the third video. Goodbye.